Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on algebraic long division, and what we're looking at in this lesson is how to complete that process by solving a cubic equation that first of all requires algebraic long division. So here I have an example: f of x equals x cubed plus 4x squared minus 3x minus 18. Given that x minus 2 is a factor of f of x, solve f of x equals 0. So key things here: x minus 2 is a factor, and what that means is that x minus 2 will divide exactly into this expression with no remainder. So the first thing to do is to do algebraic long division, set up my bus stop, divide the cubic by x minus 2, and I should get no remainder when I do that. So let's begin then. X into x cubed goes x squared. Multiply back by the divisor is x cubed minus 2x squared. Find the remainder. X cubed take away x cubed is 0. 4x squared take away negative 2x squared. Take away negative, we're adding, and you get 6x squared there. Careful with your signs, take your time. Bring down the negative 3x so that we always have the same number of terms to divide into as we're dividing by. And now we say how many x's go into 6x squared. Well, that is plus 6x. Multiply back, so 6x squared minus 12x. Find the remainder. 6x squared takes 6x squared, 0. Negative 3x, take away negative 12, we're subtracting that negative again, add 12 to negative 3, you get positive 9x, bring down the negative 18. Finally, how many x's go into 9x? Well, it's 9, positive 9. Multiply back, 9x minus 18, and as you can see there, we've got the same result as we've got above, so no remainder, 0. We expected that because we were told that x minus 2 is a factor, which means it divides exactly into it with no remainder. So what that means is my function f of x, which is the original cubic, can now be written as x minus 2 times by x squared plus 6x plus 9. I can now factorise this quadratic to x plus 3, x plus 3, and I've been asked to solve this function equals 0, which means that I've got solutions x equals 2, x equals negative 3, which is actually a repeated solution from this bracket here. So I have two solutions to this cubic. I have one where x equals 2 and one where x equals negative 3. And what you just might like to think about is the significance of this repeated root negative 3. If you were going to sketch this cubic, what that would mean would happen at the x-axis where x equals negative 3. But there we go. We're given that it's a factor. We do algebraic long division, fully factorise, and one additional step, which is to solve, which you only need to do if you're told to solve the function equals 0. So x is 2, x is minus 3 are the solutions to this equation. Job done.